I am Ivan Michael Siachans of Batangas State University, Bachelor of Science, Information Technology from the section IT 2102. For this video, I'll be showing my summary of Chapter 7, IP Addressing. So this is in CCNA 1, Routing and Switching. So let's start. IPv4 addresses. Binary is a numbering system that consists of numbers 0 and 1 called bits. In contrast, the decimal numbering system consists of 10 digits consisting of numbers 0 to 9. Each address consists of a string of 32 bits divided into 4 sections called octets. Positional notation. Positional notation means a digit represents different values depending on the position of the digit occupies in the sequence of numbers. Binary to decimal conversion. To convert a binary IPv4 address to its dotted decimal equivalent, divide the IPv4 address into 4 8-bit octets. Next, apply the binary positional value to the first octet binary number and calculate accordingly. Decimal to binary conversion. Write down the decimal number. Divide the number by 2. Write the result underneath. Write the remainder on the right-hand side. This will be 0 or 1. Divide the result of the division by 2, and again write down the remainder. Continue dividing and writing down remainders until the result of the division is 0. The most significant bit is at the bottom of the column remainders, and the least significant bit is at the top. Read the series ones and zeros on the right from the bottom up. This is the binary equivalent of the decimal number. Network and host portions. The bits within the network portion address must be identical for all devices that reside in the same network. The bits within the host portion of the address must uniquely identify a specific host within a network. The subnet mask, the IPv4 unique IPv4 address of the host. Subnet mask, used to identify the network host portions of the IPv4 address. Default gateway, that identifies the local gateway. Logical AND. The logical AND is one of the 3 basic operations used in the digital logic. The other 2 are OR and NOT. While all 3 are used in data networks, only AND is used in determining the network address. The prefix length. The prefix length is the length of bits set to 1 in subnet mask. It is written as slash notation, which is followed by a number of bits set to 1. Therefore, count the number of bits in the subnet mask to prepend it with this slash. Static IPv4 address assignment to a host. A host can also be configured with a static IPv4, such as shown in the figure. Assigning a host IP static address is acceptable in small networks. However, it would be time-consuming to enter static addresses on each in a large network. Dynamic IPv4 address assignment to a host. As shown in the figure, a host can obtain IPv4 addressing information automatically. Host is a DHCP client and will request IPv4 address information from a DHCP server. IPv4 communication. A host successfully connected to a network can communicate with other devices in one of 3 ways. Unicast, the process of sending a packet from one host to an individual host as shown. Broadcast, the process of sending a packet from one host to all hosts in a network. Multicast, the process of sending a packet from one host to a selected group of hosts. Unicast communication is used to normal host-to-host communication in both a client and server and peer-to-peer network. Unicast accepts use the address of destination device's destination address can be routed through an entire network. Broadcast transmission. Broadcast transmission is used to send packets to all hosts in the network using the broadcast address for the network. Multicast transmission. Multicast transmission reduces the traffic by allowing a host to send a single packet to a selected set of hosts that subscribe in a multicast group. Public and private IPv4 addresses. Public IPv4 are addresses which are globally routed between ISP routers. However, not all IPv4 addresses can be used on the internet. Special user IPv4 addresses. There are certain addresses such as network address and broadcast address that cannot be assigned to a host. There are also special addresses that can be assigned to a host but with restrictions to how those hosts can interact within the network. Legacy classful addressing. IPv4 addresses were assigned using classful addressing as refined in RFC 790, assigned numbers. The RFC divided the unicast into specific classes called Class A, Class B, and Class C. Classless addressing. The system in use today is referred as classless addressing. The formal name is classless interdomain routing. In 1993, the IETF created a new set of standards that allowed service providers to allocate IPv4 addresses on any address and bit boundary instead of only by a class A, B, or C addresses. Assignment to IP address. For company or organization to support a network host, such as web servers accessible from the internet, the organization must have a block public address assigned. Remember, the public addresses must be unique, and use of this public address is regulated allocated to each organization separately. Need for IPv6. With an increasing internet population, unlimited IPv4 address space issues not the Internet of Everything. The time has come to begin the transition to IPv6. IPv4 and IPv6 coexistence. Dual stack allows IPv4 and IPv6 to coexist in the same network segment. Tunneling is a method of transporting an IPv6 packet over IPv4 network. Translation, network address translation 64, not 64, allows IPv6 enabled device to communicate with the IPv4 enabled device using a translation technique similar to that for IPv4. IPv6 address representation preferred format means the IPv6 address is written using all 32 hexadecimal digits. Rule 1. Omit leading OS. The first rule to help reduce the notation of IPv6 addresses is to omit any leading OS in any 16-bit section or hextet. Rule 2. Omit all segments. The second rule to reduce the notation IPv6 is called a double colon. Can replace any single contiguous string of one or more 16-bit segments consisting of all OS. IPv6 address types. There are three types of IPv6 address: unicast. An IPv6 unicast address uniquely identifies an interface on a IPv6 enabled device. Multicast. An IPv6 multicast is used to send a single IPv6 packet to multiple destinations. Anycast. An IPv6 anycast address is any IPv6 unicast address that can be assigned to a multiple device. IPv6 prefix length. IPv6 uses the prefix length to represent the prefix portion of the address. IPv6 does not use the dotted decimal subnet mask notation. IPv6 unicast addresses. The most common types of IPv6 unicast addresses are global unicast. Global unicast. Similar to a public IPv4 address, these are the global uniquely internet routable addresses. Link local addresses are used to communicate with other devices on the same local link. Unique local, another type of unicast address, is unique local unicast address. IPv6 unique local addresses have some similarity to RFC 1918 private addresses for IPv4, but there is a significant difference. IPv6 local unicast addresses. An IPv6 link local address enables a device to communicate with other IPv6 enabled device on the same link and only on that link. Structure of IPv6 global unicast address. This address is equivalent to public IPv4 address. Internet Committee for Assigned Names, Numbers, the operator of IANA allocates IPv6 address blocks and 5 RIRs. Static configuration of global unicast address. Router configuration. Most IPv6 configuration and verification commands in the Cisco IOS are similar to their IPv4 counterparts. Host configuration. Manually configuring IPv6 address to a host is similar to configuring IPv4 address. There are two ways in which a device can obtain an IPv6 global unicast address automatically: stateless address auto-configuration, stateful DHCP v6. Dynamic configuration SLAAC. Stateless address auto-configuration is a method that allows device to obtain a a prefix length, default gateway address, and other information to the IPv6 router without the use of DHCP-v6 server. Dynamic configuration, DHCP-v6, SLAAC, and stateless DHCP-v6. With this option, the RA message suggests device use SLAAC create its own IPv6 global unicast addresses. EUI64 process randomly generated. The IEE defined the extended unique identifier or modified IEUI64 process. This process uses the client's 48-bit Ethernet MAC address. Static link local addresses. Verifying IPv6 configuration. The show interface command displays the MAC address of the Ethernet interface. The EUI64 uses the MAC address to generate interface ID and link local address. Assigned IPv6 multicast addresses. Assigned multicast addresses are reserved multicast addresses for predefined groups of devices. Solicited node IPv6 multicast addresses. The solicited node multicast address is similar to all nodes multicast address. The advantage of solicited node multicast address is that map a special internet multicast address. ICMP v4 and ICMP v6 host configuration. ICMP echo message can be used to determine if a host is operational. Destination of service unreachable. When a host gateway receives a packet that it cannot deliver, it can cause ICMP destination unreachable. Time exceeded. The ICMP v4 time exceeded message is used by a router to indicate the packet cannot be forwarded because the time lived. Testing the local stack. Ping is a testing utility that uses ICMP echo request and echo reply message to test connectivity between hosts. Ping testing connectivity to the local LAN. You can also use ping to test ability to host communicate on the local network. This is generally done by pinging the IP address of the gateway of the host. It can also be used to test ability of the local to communicate across the entire network. Traceroute. Traceroute is the utility generates a list of hops that is successfully reached along the path. This is an example of the traceroute testing the path. So that's all for my summary, and thanks for watching.